Welcome to the Teja Statistics. In BCom second year, we are calculating the trend calculations and we are studying the components of time series. In this chapter, cyclic variations. This plays a very important role. So, to understand about the cyclic variances, you can see over here the cyclic variations in a series are the recurrence of duration more than 1 year. Cyclic variation is not uniformly periodic. The most common example is the business cycle. The business cycle is may have the four phases, that is boom, recession, depression and recovery. So what are the characteristics of these cyclic variations? You can see here there are oscillating movements above and below a secular trend line. The functions occur over a period greater than 1 year. There is no uniformity in the period of recurrence of movement pattern. One cycle may get completed in 3 years while the next cycle for the same date may takes 8 years. Cyclic fluctuations are more difficult to measure. Okay, so which plays a very important role in our components of time series to understand the factors of the trend. Okay, so trend, seasonal variations, cyclic variations, these are all the components of time series which we already known in our class. Next, the calculation of the trend we are looking at here. So calculate the trend by the following method, that is semi-averages method. The name itself it is telling that it is semi-averages. Step number 1, divide the given data into two equal parts and delete the middle value if the total are odd. The given data, if it is odd, then odd number of observations if they given, then you can delete the middle one. So and then after you have to do step number 2, do the averages for the part, each part separately. Okay, consider 2D graph by taking the year values on x-axis and consider appropriate scale and you can draw this and plot the points x and y values appropriate scale by using. Okay, so you can easily understood about the calculation. This is called semi-averages method. Next, coming to the moving averages method, this is also one of the important calculation, moving averages. So here the calculations are, if the given data in years and production, if you can see the averages they calculated over like this: the 2 period moving averages, 3 period moving averages, 4 period moving averages and 5 period moving averages. So what you have to do here is, in 2 PMA calculations you have to add the two values 77 and 88 divided by 2. Do remaining 88 plus 95 divided by 2. Next 95 plus 114, that is 114 divided by 2. And like that you have to calculate all the values and you have to place them in between the values. So like that you are going to get the 3 PMA, 3 period moving averages. Here you have to consider the 3 values. In 4 PMA you have to consider 4 values. In 5 PMA you have to consider 5 values of the production. Okay, so these methods having some difficulties to know about the data. According to that we can easily able to calculate another method. We can easily able to use to calculate the trend values, that is least squares method, which is also called as Legendre's principle. So after completion of that calculations, we are just looking at the least squares procedure. So for that you have to consider a straight line equation called y equals to a plus bx. So we can write the, according to that we can write the normal equations here, that is sigma y equals to n into a plus b into sigma x for the equation y equals to a plus bx, and sigma x into y equals to a into sigma x plus b into sigma x square. So you have to prepare the table according to the given data, and you have to calculate. Let's see one example over here which is easy to understand to find the trend calculations. Find the trend line by the least squares method of the following data. Here the given year values and sales. To make it easy calculations, we are considering the simple, okay, simple and easy observations. Okay, so let the given value as a t, year value as t, and sales you already know that is a dependent variable. So we are taking the x equals to that year values minus, that is, which is the value of the middle here, that is 1978. So the data become 1976 minus 1978, that is minus 2. 1977 minus 1978, that is minus 1. 1978 minus 78, it will become 0. 79 minus 1978, that will become plus 1. And 1980 minus 1978, that will become 2. So which we already got the y values and x values over here. According to the our normal equations 1 and 2, we have to prepare the table. In our table we have sigma x calculations, sigma x square calculation, and sigma x into y, and sigma y also. So first of all you have to do sigma y, that is adding of all these sales in thousands, that is sigma y equals to 71. Sigma x will become the 0. Next sigma x into y, they did 9 into minus 2, that is minus 18. 12 into minus 1, that is minus 12. 0 into something, that is 0. And 16 into 1, that is plus 16. And 20 into 2, that is 40. If you do the sigma of x y, you got the value as 26. Next x square they did, these are the x values, squaring we are doing, and doing also summation. So that implies 2 square is 4, 1 square is 1, 0 square is 0, 1 square is again 1, 2 square is again 4. If you add of them, you will get sigma x square value as 10. By substituting that overall values in our normal equation, and we are trying to solving that equations. So here the normal equations 1 and 2 again we wrote. So here the n value is equals to 5 because you have to count the number of years of the data. 1 2 3 4 5. So here n equals to 5. Sigma y equals to 71 equals to 5 into a plus b into sigma x value is 0. So 71 equals to 5 into a, that is equation number 3. From that we got a value as 71 divided by 5, that is 14.2. Similarly, from the equation number 2, sigma xy, we are writing sigma xy is equals to 26 equals to a into sigma x value as 0, b into sigma x square value we got 10. So 26 equals to 10 into b, that implies 26 divided by 10, that is b equals to 2.6. So here our main target is to find out the constants a and b. Hence we calculated that one. So our required trend line or a straight line equation for the given data is y equals to 14.2 plus 2.6 into x. This is how you have to fit the equations. By the way, we need to know here the Legendre's principle also. What do you understand by the Legendre's principle? So here they given the sum of the squares of the deviation is a minimum. The sum of the squares of the deviation is minimum. Here they given that least squares principle, or we can call Legendre's principle also. So this is how you have to calculate the least squares trend calculations by the method of least squares, which is also known as Legendre's principle. Okay, thank you for watching this. Please do subscribe and also like and share. Thank you.